We all think we understand glaciers. Massive bodies of ice high in the mountains and vast ice sheets covering entire continents. We have all seen the images. Enormous structures of ice collapsing into the sea, explained as evidence of climate change. Polar bears stranded on shrinking platforms of ice, ecosystems disappearing. In his TED Talk on Time and Water, published in 2021, Icelandic writer Andrisnir Magnason says in his talk,
I wrote a poem for a plaque that was placed on the mountain where Okjökull once stood. It was a letter to the future, and it says, "This monument is to acknowledge that we know what is happening and what needs to be done. Only you know if we did it."
The melting of glaciers has become one of the most powerful images of the climate emergency. But when you spend time with the scientists who study this ice, from mountain glaciers to the vast ice sheets of Greenland and Patagonia, you begin to realize that our understanding of ice is still surprisingly limited. Because what we know about the frozen world of our planet may be only the tip of the iceberg, and the phrase has rarely felt more literal. In these 2 episodes about the planet's ice and its relationship to the climate crisis, I will introduce you to 3 scientists who work in MARUM, the Center for Marine Environmental Sciences at the University of Bremen. Together, they study ice, from the mountain glaciers of Patagonia to the ice sheets of Greenland, from computer simulations of the past 127,000 years to marine sediment cores drilled from the ocean floor, and all of them connect the ice to the same place, the ocean. I am Juan David Escorcia. I report on the environment, the climate emergency, and the ocean, uncovering what's changing beneath the surface and what it means for all of us. This science journalism project was developed as part of the Frontiers Fellowship, funded by the European Union. Professor Ben Marzeion is a climate scientist in the Department of Geography at the University of Bremen, associated with MARUM. I walked into Ben's office and the first thing I noticed were the photographs on his wall. Glaciers from around the world, including some from the Peruvian Andes. I immediately thought of a sentence from a UNESCO report titled "The Voices of Glaciers," which brings together testimonies from indigenous peoples in the Andes about the melting of glaciers and the need to protect these sanctuaries of ice. I asked my journalist friend Judith Sarmiento to read the sentence for us. She lives in Armenia, a city in the Colombian Andes, and every morning, from her window, she has coffee while catching a glimpse of the glacier of Tolima, or better known as Dulima, in native language. This is the sentence she reads for us.
For many indigenous peoples in the Andes, ice has a sacred character and must not be disturbed. A glacier is an element of identity and the center of their spirituality. Degrading the glacier disrupts the structure and social relations that allow the harmonious functioning of the system.
From that perspective that indigenous peoples attribute to glaciers, I had the opportunity to talk with Professor Ben, a scientist who has spent years explaining from science what the ice is doing and how fast it is disappearing. Back in his office, surrounded by photographs of glaciers from around the world, Professor Ben explained his work. There are more than 215,000 glaciers on Earth, and he builds numerical models to simulate how each one of them responds to climate change. But what exactly is a glacier?
Yes, a glacier is a body of ice that is moving and typically found in mountains. Not always high mountains. You also find glaciers at relatively low elevations if the climate is cold enough. But essentially you get a glacier if every year, every winter, more snow is falling than is melting away during the summer. So when that happens, the snow starts accumulating year after year. Because the snow is heavy, it's being compressed, especially down within the glacier, and eventually it turns into ice. And on a human scale, the ice feels really hard and it looks really hard, but really it's not that hard. It's deforming, it's flowing. And if this is happening in the mountains, the ice starts to flow down the mountains. And by flowing down, it's reaching elevations where the climate is warmer. And so there, then the ice melts, and more ice melts every year than snow is falling on top. And so a healthy glacier works like that. It's accumulating snow high up in the mountains. Ice is flowing down into lower elevations where it's warmer, and when then there, the ice is melting. And if everything is in balance, then every year melts about as much ice down in the valleys as snow is falling on top of the glacier high up in the mountains.
That is a healthy glacier. But the glaciers we have now are not in balance.
And the ice that was stored in the glaciers is running through the rivers, and most of it is ending up in the ocean eventually. And so this means that the melting glaciers are contributing to sea level rise. And if we look at the past 25 years, they have contributed almost 1 millimeter of sea level rise every year. Now 1 millimeter may not sound as much. The total amount of sea level rise is between 3 and 4 millimeters per year. And that means glaciers are contributing a substantial amount of that, right? So we have lots and lots of glaciers, more than 200,000 actually in the world. And each of them is really small, especially if you compare them to the ice that we have in Greenland and Antarctica, the big ice sheets. The glaciers in the mountains that we are talking about store less than 1% of the total ice. Roughly 10% is in Greenland, and about 90% are in Antarctica, and then a little bit less than 1% is actually in the mountain glaciers. But still they are contributing about a third or a quarter to total sea level rise.
1 millimeter per year, every year, just from mountain glaciers. That might sound small, but behind those numbers is something that Ben discovered over years of research. Something that surprised even him.
Well, one thing is, and again, it's coming back to the glaciers are slow to respond. One thing we very clearly see is the glaciers will keep melting for many decades and probably even centuries. So they are starting now to respond to our emissions of the past. But even if we would stop emitting CO2 completely today, they still would actually melt substantially. So if we could stop climate change today, 40% of the ice that we have in the mountains would still eventually melt. Because the glaciers are still sort of catching up with the climate change that we already had in the past. Over the next, let's say, 30, 40, 50 years, the glaciers are still busy responding to what we did in the past 50 years. If we are really ambitious now in reducing CO2 emissions, of course we should do it. There are many, many reasons, not just the glaciers. But we can't expect that, 5 years later, we will see the impact of that in the mountains.
But the question is, why does this matter for the ocean? And why is a glacier scientist associated with a marine research center?
As the water from the mountains is entering the ocean, it's actually changing the ocean because the meltwater from the glaciers is fresh water. So where we have lots of ice melting, we are affecting the salinity of the ocean. And the salinity, again, then is important for the ocean circulation, for example. When you sort of start then looking at the interactions, then you see in some places it's also the sediment that is brought into the ocean. And the ecosystems are depending on the amount of sediment. If you have much sediment in the water column, the water is relatively murky, it's dark, algae can't grow there. If the glaciers are changing, these conditions are changing, right? So then you have the connection from the glaciers to the marine ecosystem. The marine ecosystem, again, is linked to the carbon cycle and so on. So you find interconnections within the Earth system almost everywhere. And the glaciers are one part of that. In some regions, they are really important. If you really want to understand, what is the freshwater budget of the Arctic, you really have to consider the glaciers. And then if you want to understand the ocean circulation as well. In other regions, you can explain why there is a link, but probably the link is not going to be very strong. But you can sort of see connections almost everywhere. I would argue. And sometimes the connections are a little bit further and not as strong, and sometimes they're really surprisingly strong.
In the second episode of this series dedicated to understanding ice, we will travel from north to south. In the north, Dr. Rebecca Jackson will take us to Greenland, where marine sediment cores from the ocean floor reveal that ice sheets don't always retreat when temperatures rise, and where the melting of glaciers threatens to disrupt the ocean circulation that keeps Europe's climate livable. In the south, Dr. Andrés Castillo will take us to Patagonia, where a massive ice sheet reached its maximum extent before anyone expected, and where the models that failed to explain the past are the same ones we are using to project the future. I am Juan David Escorcia. I report on the environment, the climate emergency, and the ocean, uncovering what's changing beneath the surface and what it means for all of us. This science journalism project was developed as part of the Frontiers Fellowship, funded by the European Union.